Compose, we learned about like how to create a project in Jetpack Compose, some of the very basic composables like text composable and like basic set of layouts. Tonight, we will be learning furthermore, but before I introduce our wonderful speaker for tonight, I'm going to do a little bit promotion for my team because why not? All right, so let me go ahead and share my screen. And all right, perfect. So, I'm Sagar. I'm one of the co-organizers for Google Developer Group Boston Android, and we have got like other co-organizers you can see on the screen. Beth Engine, they're online. So if you haven't joined our Boston Android Slack group, then I would advise you to join right away. Here's the link you can see on the screen. We are pretty much a dormant group, but we definitely come to the rescue if someone has a technical question in their mind. So feel free to join our Slack group, send a question in like general channel. We have got like other few channels dedicated to few selected topics, if I'm not wrong. But for this particular Jetpack Compose camp, which is running throughout the summer of 2023, we have created a dedicated Slack channel, and that's compose underscore camp underscore summer 23. So feel free to join over there and log your progress in the camp as and when you are learning new things in Compose. If you have any questions specific to Compose, then post over there. If you have got like open source projects, then feel free to share over there and we will make sure to collaborate with you and then, yeah, find contributors. It's going to be beautiful. Now, for tonight, we have a very special speaker who is sitting right behind me. And that's Dan. So he's going to introduce himself in a while I stop sharing my screen.
Cool. Oh, it's all right. I think we got rid of the echo there. Hello, everyone. Could someone give me some sort of, notification you can hear me okay, or maybe like a thumbs up?
Yes, we can hear you okay. We can hear you then.
Message in the chat. Just want to make sure that everyone can hear me okay before getting started. Cool. Thanks, Jen. All right. Well, let me go ahead and share my screen. I have to give it permission. All right, looks like I need to quit and reopen Chrome, so I'm going to join the call in just a second. Sorry about that, folks. Yeah, sorry about the technical issues, folks. We're currently just trying to share the screen. It looks like we're just doing the entire screen. Chrome doesn't want to share a window. Say okay with me. All right. Can everyone see the screen okay? I guess I can sort of look to the left and see that.
Yes, we can see it.
Let me just pull up the presentation. Cool. All right. Sorry for the delay, folks. Really happy to be here today. I've been following the Google Developer Group for about a year and a half now. Basically, as soon as I kind of got involved in Android, I worked for a couple companies in Boston that were part of Intrepid, which then was acquired by Accenture, and I kind of started to learn a lot about the Android community as it came. And it seems like, from my perspective, there weren't as many people kind of getting excited about Android and around the 2020 time. It felt like, there was sort of a period where a lot of younger engineers were being developed to become Android developers, and kind of the golden age of mobile development. But as someone who graduated recently, and was in college and kind of wanted to learn more about Android development, I really didn't think that there was a lot of communities for it. So, I'd always heard these stories of so-called like Intrepid engineers and other kind of Android engineers in the area, who had kind of worked together and had, Kotlin conferences, DroidCon conferences. And I really wanted to get involved in that. So really happy to be here today. It looks like it really went with 2 profile pictures here. I guess there was like a deletion. We'll go with the drumming one though. Very nice. I'm currently working for Peloton as an Android engineer. I've been there since November. Before then, I worked for Whoop, which you might know as the company that's kind of right next to the Citgo sign in Fenway. Some BU students got pretty upset with that, but no longer with them. Before that, I worked for Python, which is another Boston-based startup. That was actually where I started to learn Compose. Basically, as long as I've been doing Android development since around 2019, I've been kind of tinkering around with Compose. And a lot of that kind of came from working at startups beforehand and having experimental tech mentors who were okay trying out the alpha and so forth. So been working with Compose for quite some time. Definitely seen it improve over the years. I've also kind of been fortunate enough to work in areas where I actually have kind of built out the design system for Compose within a legacy code base. A lot of the challenges in Compose, I think, are getting the kind of leeway to sort of have a company agree to use this new experimental library. There's a lot of things that are wrong with it. There's sort of some bugs and such, and definitely it's not something that you want to rewrite your whole app with at first. But building out kind of a design system and building that initial infrastructure to use Compose with is something that I've been doing for quite some time now. I'm also realizing that this is really just, butchering the pieces here. Anyways, if you want to check out my portfolio, it's just paluso.dev. That was all written in Flutter. I'm a big Flutter fan, kind of on the side as well. And I'm living in Cambridge, part of the Northeastern community as well. But that's enough about myself. We're here to talk today about Jetpack Compose. This is the future of Android UI development. You've probably heard people get excited about it, and there's plenty of good reason to. As someone who's been using it for a few years, I can definitely say that it makes development up to 10 times faster, and especially the practices that are involved in it. I've never met an Android developer who doesn't like Kotlin. I think that Compose is really powerful in leveraging Kotlin to make UI a lot more discernible and readable. Maybe if you've been doing Android development for a short amount of time, or even maybe if you've been doing it for a long time, you can remember that opening up an XML file, especially at a serious company, is kind of a scary thing. There's constraints everywhere. There's attributes. It's sort of this HTML kind of mess. You're not really sure how the views connects to the code. And I think one of the biggest benefits of Compose is that it really kind of marries the view and business logic into this hierarchical sort of structure. So, I'm sure you guys learned a lot about that last. We're going to be kind of kicking off today just to sort of give a brief overview of the things we're going to go over. We're first going to talk about event handling. This is basically your system of communicating with composable functions and having those composable functions kind of call back lambdas to actually perform an operation. We're going to talk about the remember function in Compose. This is really one of the most important pieces of Compose, as it kind of gives you your introduction to state hoisting and recomposition cycles. You've probably heard that Compose is really specialized to recompose things in kind of a hierarchical manner, and states are kind of coming from the inputs of a composable function. That's sort of the basis of it. But let's say you want to have a view where the input doesn't really change, but you still want to have something within it update. The best example of this, I think, is having a text field. Now, you could supply a text field with a parameter about the current value of that text, but that's kind of an intensive maneuver, and you're going to be going back and forth a lot for just changing one thing. Really, if there's a piece of information that is going to change and you want to associate that state with the view rather than the parent view, the best way to do that is with a remember function. So we're going to talk about that after. We're next going to go into theming, which is really just a way to make Compose adaptable for any kind of environment. If you're an Android developer, you're probably familiar with the millions of different screen sizes, resolutions. Android is used by people who like really small text on a very large screen, but it's also used by people like my grandmother who like really, really big text in kind of a much smaller kind of a legacy device. Compose has a lot of things that can help you sort of adapt to that and make it so it's a little bit less of a headache to deal with it. And that's sort of the basis of theming. The final thing we're going to talk about, or maybe we'll have some time for more, but we're going to then talk about lazy lists and layouts. Essentially, this is sort of the way of doing a recycler view if you're familiar with Android development. If you're not familiar with Android development, basically what this is a list that kind of redraws itself and is computationally less expensive than kind of drawing the entire list out at once. If you wanted to make a column in Compose and fill it with 500 items, and you did that inside of a column composable, it's going to try to draw all 500 of those items at once. If you do it within a lazy list composable, it's going to kind of smartly render those, and it's not going to lag out and give you any A&Rs or anything nasty like that. So it's a very important library to learn early on. Finally, if we have time, we're going to talk a little bit about animations and, kind of the benefits and sort of some of the basic APIs that you have to use when you're making your app in Compose. I think a really big benefit of Compose is it kind of demystifies animations a little bit. You can kind of do things like tweens, expanding, kind of movements around in sort of a linear fashion. And the API actually makes it pretty simple. There's a very beautiful chart that we can look at later that kind of shows you how to decide what sort of animations you want to use. There's quite a lot of examples, which we will hopefully get to. But, without further ado, let's kind of go into the event handling and get started with that. I guess another thing that is tricky is because I'm screen sharing on here, I actually can't see the chat and any questions. So potentially, if you do have a question, maybe one of you guys in the audience could sort of trigger me. We don't have to wait until the very end to go into a question. If you have one, let's just kind of answer it as they come. For spending a little bit more time on it and it's more of an individual thing, maybe I can talk about it later. And of course, I'm in the Slack channel. So anything that you feel like you weren't able to get in, please DM me directly. I've been, kind of mentoring people in Compose for a couple of years now. And I do genuinely love getting people on top of it because I think that Compose is just code that I prefer to write and code I prefer to edit and review and such. So the more developers we can have using it, I think the better. All right. So maybe you have this repo cloned and you're following along, maybe not. Either way, we're going to be kind of looking at examples pertaining to the Jet Survey repository. Jet Survey is essentially just playing into this kind of like Compose anime that they have with these characters, Spark Lens, the Bug of Chaos, and Frag. I'm just kind of realizing now that I guess those are subtle Android references, but if you want to follow along and sort of see some good examples that go with this presentation, go ahead and clone that repo. I will warn you, you need at least Android Studio Flamingo and at least Android or Java version 17 to run the project out of the box. If it's not super obvious, that was my limitation about running this. I'm running Amazon 11 Corretto, but that's okay. I have another project up that we can do some examples with that works just fine. So, we have this kind of single answer object. I believe that you guys got up to around this section, 83, is it? Or to modifiers, does that sound right, Cigar? Cool. Yeah, so, imagine that we have this row composable here. Looks pretty straightforward, right? You're going to have an image going into a text, going into a radio button. Now, this is kind of just a high-level simplification of it, right? There's a little bit of modification happening to it that we can't actually see from within this view here, but you kind of get the basic gist of it. Now, what might be new to you is this sort of on-click parameter from within the radio button. If you've been working with click listeners in XML, this is kind of your way of calling a Lambda function when something gets clicked on. So in the most basic form, this radio button here has 2 arguments. You have your whether or not it's selected and what you want to happen on the click function. So in this example, they're kind of taking this and then putting it within a composable list. You can see here, it's not a lazy column, as I was mentioning earlier. This is a static column. But basically, in most of the cases with this, you're going to want a list of items, each with kind of their callback. And so the way you would specify that is with this kind of composable column here. I believe this might be getting more into the lazy list aspect of it. So potentially we want to go to just the code itself. Yeah, I think we're going to open up the code directly. Cool. So this is just a basic Compose application kind of built from the out-of-the-box Android Studio composable basic empty project here. As you can see, we kind of have our main activity. This is the super important set content call, which is going to actually render everything. And then you have your theme here, which is what's providing kind of text assets, colors, things that you don't want to have to worry about within the actual code here. So I have an example for later that's in there right now. Let's go ahead and comment that out and look at button example or event handling example. So we're going to put that right here, and then let's check out the device. Now, before we actually run it, the preview aspect is really one of the biggest benefits of Compose. Sometimes you'll work with companies with XML that don't actually have this, but this one fortunately does. So let's look a little bit about the button API here. Your first argument, and this is just generally good Compose practice, something you're going to want to do is name your parameters in every case here. It's good to get into the habit of this because it makes it a lot more readable. In the presentation, you kind of saw that they had this, the false here, but then the named on click. Now, in this case, it's a little bit obvious, right? But it can seem obvious when you're making these composables, but maybe not obvious to the developer what arguments you have there. So in this case here, we have our on click, and then following kind of a standard composable pattern, opening the brackets up after this, you see exposes the content right here. Once again, this is annotated with the composable. So anytime you want to really know what sort of the API looks like for your composable, highlighting over it and using syntax highlighting is super helpful here. In this case, we have a composable, and you can also see that we have it in row scope. What the scoping means is that if I was to, within here, add another piece of text, or maybe I want to add in a spacer, let's give it modifier size, something like 3dp, pretty small. Zoom in, yes. I think I can increase it to this level. Is that a little bit better? Cool, yeah. Sorry about that, folks. Cool, so yeah, you can see I had a spacer in right here, and then let's add another text view. It should appear to the right of the button. You can actually see my spacer has already grown, and you have this here. It is important to pay attention to these scoping aspects, and it does, remind you of it right here. But this is just kind of showing you that whatever is built inside of these brackets is going to be in the context of a row. Moving a little bit aside, though, and we have our button here, and we have our on-click. Nothing happens in it right now. This is kind of the most classic example in all of software and engineering. Let's go ahead and give it a hello world on the on-click. Now, right now, the preview window is kind of in static mode. We're not really doing anything here. But if you want, you can run interactive mode, which should let you actually see what happens in the context of your event. I wonder if it happens potentially not on logcat. Is it in this terminal? No. Okay. Well, I guess this is just attached to the run window, not interactive mode. So I'm going to go ahead and stop that, and we'll pull back up our emulator here. Run the app on the Pixel. Oh, you can see it is a massive button, but, kind of my app running window. If I press it, we should be able to see hello world coming from it. It looks like this is not attached to the window itself. Well, let's try to do another example of kind of an on-click. Yeah. Oh, maybe I have to do it from down there, actually. Here we go. This looks like it does not. Oh, here we go. If you do good old logcat, you can see the hello world is kind of appearing here in just kind of the system out level. I guess it wasn't on the run. So you can kind of see this Lambda gets opened up. We're doing the most basic operation here. Your on-click gets passed. Now, if you actually were to make this kind of a more advanced composable with the on-click specifically, you're probably going to want to have the on-click as a parameter of the parent. The most basic way of kind of doing this is by declaring the field type, which is a lambda. It's going to return just unit here. Let me put my colon. Cool. So now when we do on-click, we could say on-click equals on-click. As you kind of notice here, the spacing makes it a little bit funky. We actually, if you do something with this, we can try to rerun it and then click it. I might get yelled at in the upper level because we didn't pass it an on-click. Very nice. So go ahead and add that same print line up here. Hello world 2, we call it. Okay. Go ahead and cut that one out there. So as you can see, we didn't open up a lambda here. We're kind of just saying this on-click is going to be equal to that on-click. Let's try to run it. Go ahead and delete my existing logs. So in this case, because the path is the same, it's looking for kind of the same argument of just opening brackets and then taking a unit here. This will actually work. Now, if you also do it with this, opening up the lambda brackets can pretty much add anything here. So let's say you want to call your on-click function. Let's say you also maybe want to do a print line statement with something else here. Maybe just want to repeat the word world. That's A-OK. This kind of allows you to not only take the on-click of the parent, but also kind of add in your own logic here. So I don't believe this one ran. Maybe we have to do it from up here. There we go. So now we should see on our logcat, we do hello world 2 from the parent, as well as kind of this function here. So really inside of this parameter, you definitely want it to be within the parent, but you also kind of want to add any sort of effects that you could do in addition to that on the composable. Now, just to kind of tie this back into a real world example, a lot of people, when they create apps, will have analytics around those sorts of events. Let's say in this example, I'm a product person and I want to see how many times a button gets picked here. This would be a really good example of kind of opening up this lambda from within the event and using it from inside. Let's say I have, some analytics class dot like on button clicked. I can kind of call that from within here in addition to actually performing my function. So analytics calls can be done from within the composable if it's just going to be a view level thing. So that's kind of the basics of event handling here. I think that it makes sense to probably go right into remembers because as you can see, this is nice. We can pass this here. Basically anything that we want to happen, we declare from the parent class, as you can kind of see in the main activity that's happening right here. But let's say you want to have the event actually only modify the composable itself. Maybe I want to have an example of something where this on-click is actually going to change the text from right here. So what would that kind of look like? First we'll go ahead and get rid of that and remove something here. This is where we're going to get into the remember statement. Now, this is something that you generally need to do quite a bit of imports for. So if you're following along, you're probably going to be pressing Option Return quite a bit, or Alt Enter, I believe it is on Windows. Essentially, the remember statement is going to, when changing a value, trigger a recomposition on just this composable's level. So let's kind of do a very basic example here. I'm going to go ahead and make a var, call it, my text. Looks a little bit like Hungarian notification, so I'm going to go ahead and change that. Var name equals Dan. So if I, on the text, refer to the variable here, and in the on click, I say name equals Jerry instead. Let's run that example and kind of see what happens on the button press. Oh, a nice little compilation error. Love this. It's because I changed my contract. Fair enough. Okay. So, maybe the behavior that you want is that as soon as you click the button, the text on here changes. Let's go ahead and give that a shot. See our lovely splash animation for a button that takes up the whole screen. As you can see, nothing happens here, right? The reason for this is because Compose is waiting for some sort of trigger to redraw itself with information that's coming inside of it. In this case here, we have just the name variable. If you wanted to, you could have the name come in through this side, but let's say we only care about it on the level of the view that we're doing. That's fine. We just need to use the remember statement. The way that you do that is using this kind of Kotlin by aspect. You kind of open up a remember calculation, and then you give it a state. So in this case here, we're going to do mutable state of name. That's kind of your initial value that you have here. I guess I can go ahead and make that Dan. Now, when you do this on click here, you're not changing just a string. You can see that it's actually a little bit, more complicated than that. There's a calculation involved, and this is going to kick off the entire composable kind of redrawing. A good way to kind of debug generally if you are redrawing your composable is, classically just with a print line statement here. You can kind of see this recomposing is going to show us when we actually rebuild the view. So kind of the key takeaway here is that nothing in the parent has to change. You can see there's no input arguments, but we are going to trigger a recomposition internally with this remember statement. Let's see what that looks like. Very cool. So we see Dan initially. Wow. Right to Jerry. Very cool. So as you can see, I don't believe, maybe I have that. Okay. Recomposing went in. Now I can press it again, and you can notice it's not recomposing again because Compose is smart enough to know that if this variable isn't actually changing, which in my on click, it's not very creative, right? It's a one-time change that's happening here. It's not actually going to recompose anything because that value is not changing. Let's try to change that so that we can actually see how our recompositions will impact this. So rather than just setting it to Jerry, let's say name plus equals name. You can kind of maybe predict how this is going to behave here. Essentially, we're just going to start repeating the word that we have. So I'll press Dan. Once again, it becomes Dan, Dan. It's increasing. You have to remember logarithmically. So Dan, 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 and so on and so forth. If we go to the logcat and kind of check for recomposing, you can see that this gets triggered only on the top level here. Now, the reason for this is because name is actually not being used on this top level composable, but only on the text value here. So within the scope of the row, we see that name changes here. Let's go ahead and add a cute little dot also statement here and see if this gets called every time our text gets called. If you're not familiar with Kotlin, and also is kind of just a way to really just daisy chain any sort of logic onto something with the context of that in. So what I would expect to happen here is that you print on recomposing just because this text is being redrawn. Okay, so we're getting our many Dans here. That's fine and dandy. And you can kind of see on this level here, now we're finally seeing that the recomposing is happening. And this is kind of a real live example of Compose kind of doing this hierarchically, because on the top level, nothing's changing, so nothing has to. This compiler is a lot smarter about that. On the actual individual level in the view where you have an input parameter that is changing, that's when we kind of see this recomposing value start going. And every single time we press it, we're triggering a recomposition. Now, When you're starting off, maybe you don't want to worry about recomposing, and that's fair. But as you kind of start to scale the composable functions, it is important to kind of pay attention and make sure that it's behaving properly when you make that view. So just be sure to kind of monitor some points when you're recomposing things. There are sort of profilings that you can do regarding that. I'm not going to attach a session just because it is a little bit of a memory intensive thing here. But yeah, you can see that this composable is kind of redrawing itself every single time. Now, this is sort of a basic example, right? We have just a button. All it's doing is changing that. Really, just the on-click parameter is fairly straightforward. But you can kind of change it in any sort of direction. Let's say you want to, instead of having a string mutable state, you want to have a Boolean. Now, this is really helpful when you want to trigger some sort of visibility or some sort of color action, and you want to have it be based off of a Boolean value here. So go back to naming the button Dan. Our on-click is going to say name is equal to not name. Essentially, this is just meaning the button is going to become a trigger of what kind of color we have. Now, nothing's changing here. You'll see that the parent button maybe will have a different input, but we're not actually using the name. We're just setting it here inside of our composable. Let's go ahead and add some sort of change that we can do here. Maybe something like color. Inline this value here. If name, let's do color dot red, else color dot let's go with green. This is going to ideally look absolutely hideous on a purple background. We're also not using our composable theme here, but we'll get into that. Okay, so right off the bat, you can see that my first value is false. We haven't done anything to click it here. We kind of go into this else case, and my text background, a bit small here, so maybe I can zoom in. There we go. This is kind of that triggering happening. Once again, a recomposition is occurring here. So remember, it doesn't necessarily have to be text. It can be a Boolean. It can be, a different sort of state here. If we kind of open this up and look at the mutable state of API, you can see that value is really T, right? So we can have it be any sort of thing here. There are different sort of structural equality processes or policies, they call them. So you want to be sure that your dot equals and your hash code is kind of properly done if you are doing a custom object. But in this case, we're not really doing that. Now, kind of drawing back into a real world example, I mentioned this one earlier. What is a time where you would want to use or remember internally? Now, the most basic example of this is with a text input. So this is just kind of another example here. Let's go ahead and try to do our own textbook or our own text input. Have our event handling example here. This surface is kind of just centering anything that we put in here. This background color is pretty rough, but that's okay. Let's go ahead and make a little text input. So we're just going to start off with a column. Let's kind of give it some, pretty alignment here. We're going to center it horizontally, and we'll give it an arrangement so that everything kind of goes within the center. Inside of the column, we're going to start building our text input here. So you can already see that there is this text field value here with both the value and the unchanged. Let's kind of start performing some state hoisting and give kind of the parent view some responsibility here, which in this case is just kind of our highest level composable. So we'll give it an initial value, maybe something like, hey. Now we have inside of here, we need to actually make the initial field, maybe give it a default value as well, just in case. So now we have our initial value. It's all fine and dandy. Our on value change kind of gets added here. What do we want to put inside of it? You notice that you actually do have a function that will pass you a value. This is basically saying it here becomes whatever string the user has typed in. So if I want to print line it any single time the value gets changed, this is going to show us basically that This gets triggered any single time a text is put from within that text field. So we're going to add our remember value at the top. All right, var current text. I remember. It opens up those brackets. Let's do mutable state of, and this is actually probably a better spot to put initial. This is going to change internally here. It doesn't think we're changing it, but we will do that momentarily. Current text equals it. So now you can see that the text field gives you a lot of control of the parent view by kind of giving us this current text field that we have here. You know, in the example of maybe you want to have an on save happen here, something that takes a string and with it sort of performs some sort of function on here. Unit is kind of standard across passing lambdas to your views. You know, you don't want the on save to get called every single time a text is being edited from within your composable here. You really only care about it when someone is done with it. So I have my column here. I have my text field. Let's go ahead and put a button underneath it. When you click that button, that's when we can call our on save and give it the current text that we hold on to locally. So this is kind of a way that the child is then telling the parent view, okay, here's the information that you actually care about. Let's perform an operation on it on a level above that. So, you know, inside of our parent, it's probably going to yell at us because we don't have the on save function. You know, simple as we've kind of been doing everything else, we can see that I kind of created this to have a string as a value here. So when I declare it here, a string is going to be what I need. So on save, let's do just another print line example. Saving string, and then we're going to inline the variable it. So what we should see is that we do print the value. Maybe we can make this a little bit more clear to see. Current string equals it. That's going to go every single time it changes, which recomposes this button as well as this text field here. And then we sort of pass that up to the parent, which we can see in our example. It should print line this saving string. Now, I didn't do a ton of styling on the view. I don't know if I immediately will get this right. Looks pretty good, though, immediately. No text on the button, but that's okay. Let's go ahead and check out what the print line looks like. Here we go. You can kind of see from my log statement, this is getting called anytime the value changes in here. And maybe you would want that, maybe you wouldn't. But what's important is that only this composable is going to care about that. Current text, similarly, it just is happening whenever you do something here. So current string equals that. Current text is updated every single time that this is changed. So you can see it really just makes a mess if you are printing this out on every level. But let's kind of bring it back to hello world. And then I'm going to click save. And you can see this was from the parent. We're printing it out as saving string here. So anytime you want a text field, you're going to want to have the parent kind of perform something on maybe just the save action. And then locally, you kind of care about just what's getting updated from within the text. Now, made sense to me kind of explaining it, but obviously like these event handlings kind of passing around lambdas might be a bit confusing to newcomers. The remember, I think, can especially be tricky with recomposition. So if anyone has any questions, it would be a good time to ask them now. I definitely understand it could be a little confusing on sorts, and especially with kind of the mythology or what is it? Methodology of how compose works. It can be a little unfamiliar. So maybe coming from XML, you might, wonder how this is doing it. It's a good time to ask questions. Do we, cool. So, everyone's following along well, going at a decent pace. Cool. Cigar's nodding, but he works in compose, so might be a little biased. I'm gonna grab some water, but cool. We can move on to the next thing. Okay, how do we doing on time? Doing well on time. So the next thing that I kind of want to talk a little bit about is theming. And I think in here, potentially they talk a little bit about maybe. Okay, yeah. So going back to the presentation, this is just more about layouts kind of, but you can see eventually we kind of do get to the remember statement, which they end up adding here. In this case, they have their own object, an answer class, as they call it, which starts off nullable. You can do that because you have this question mark right here. Once again, has to be set as a variable or a var if you want it to be mutable. We can go down to this aspect here. You can see that this survey answer is going to have an is selected function where we sort of compare it to the value here. So this is them kind of building a radio group and deciding which of the radio button is going to be selected. Now, we have it within a list of items, and so you can see that that's what they're doing right here. Did you guys go over for eaches and columns in the last class? Okay. But you guys do understand how basically to build this, we're taking our list of answers as an input, we're iterating over each of them, and then this happens within the context of this composable. We kind of print out a survey answer here, right? Answer kind of being your value. I can also show this because this is kind of an important concept. Let's say you have items, which is a let's call it a remember state of list of. Go ahead and make it a var. Gotcha. Cool. Okay, so I'm going to bring back my button, which is going to live at the top here. Basically, anytime we click it, we're going to mutate this state internally. So let's go ahead and say items add. So I'm not going to expose that to me. There we go. Always keep it mutable. Items add. We'll add these to the top. Go ahead and do math.random toString. Cool. So we're basically just going to add a random kind of integer every single time to the list here. But, we sort of have just a generic button that's doing this. We aren't actually displaying the item yet. Add number underneath it. The button, this is where we're kind of going to do our iteration here. So we'll take items.for each, opening up the bracket here. Our context of the items, because it is a list of strings, becomes a string. And now we're going to make just a basic text where the string is that. So now anytime we click a button, we should be able to add a random number to the top of the list, and it should display in this row that will grow from the center. And maybe won't look that pretty. That is okay. Let's see what that looks like. All right. So it didn't like that. Potentially the text is the wrong color here. Oh, yeah, no, this should put it within the context of the column. All right, I guess it did not. Regardless, going back to the presentation, you can see that in this case, they're using the mutable state of this answer to just determine which of the items is selected here. So you kind of give it this piece of conditional value here. The parentheses is going to make this a conditional value here, and it will only select the answer that is from within this internal value. This is kind of a diagram just showing the basic piece of what we had here. The state gets communicated to your composable, and then the event is kind of brought back to the event handler. In the case of our button, the state was the text that we gave it. The event that we gave back was sort of that on click for the save on the text input there. So in the case of their radio group, you kind of give the list an answer. When you click on it, it will call back this on answer selected. And then the event handler sort of changes which is the selected answer in this remember statement. So going back to it, you have this remember savable, selected answer. By the way, remember savable, this is a little important, is just a remember statement that is independent of configuration changes. So classic Android example, someone rotates their screen, remember savable is not going to lose the context of this value. It will hold on to it. But going back to kind of the diagram here, your answer is changed. You call the on answer selected, which then will give a new selected answer to the root element, and it will then change the selection status because you retrigger composition of survey answer, and you can see this is selected is actually what will kind of change what the view looks like. All right, this is just kind of more generic stuff. I think this is basically it for what we can put or what we want to look at inside of here. This is an important concept. This is kind of going back to what I mentioned earlier. Recomposition is supposed to be as smart as possible. So you're going to be able to, in the case of the button where it was a button and a text, the button didn't actually change, just the text did. It will avoid kind of re-rendering that, and it's going to be a less intensive process for the processor. It's also optimistic, which basically means that it tries to recompose everything before a parameter changes again. This is kind of only relevant if you're sending a lot of events to the parent and then passing it through to the child at a very quick pace. And a lot of times with those, you're probably going to want a better method of listening. Further down the line, we're going to learn about collect as state, which is sort of how a view model would communicate that. But it is important to know that compose kind of expects to finish drawing before it gets a new value on the input. And they might run frequently. As you kind of saw with my text input example, every single time I changed a letter inside of it, everything kind of got recomposed from scratch. That works fine for a text input. It means it's a relatively inexpensive operation. However, if you were to do that with, let's say, start kicking off an animation every single time a letter in a text view changes, that's going to be a lot more expensive, and it's going to potentially cause an ANR or bog down your processor quite a bit. So, we have these pieces here, kind of went over the mutable state and remembers. The parameters is really the what triggers the recomposition if you're not using a remember statement. Let's kind of move a little bit into theming. I thought they had an example of that, but no less, we can kind of work with this one. So you can kind of see in this basic compose empty activity, we set the content, and you're actually in compose land at this level. Like you could put a text view here outside of the context of a theme. What you would notice, though, is that it's not going to have the typography, colors. I don't have access to any of these kind of pieces. So let's say I want to change the text of the color. Color equals, I want to use material theme. I believe I do get it here because, well, it will compile locally anyways, but when I actually try to run that, it's probably going to give me an error about not liking this compose theme right here. Okay. Yeah, so it doesn't show it on the view here, but basically it needs to be within this actual specific application theme. I kind of see what happened here. So let's say I want to do compose application theme. What most kind of enterprise setups for this will do is actually combine this composable function with a global object that hosts your colors here. Material theme kind of comes free to anyone, so this wouldn't really happen here. But you can see it is a pretty basic theme. We kind of have standard typography from material stuff. They kind of just recopied it into this piece. From a high level, though, I think that discussing kind of why we use theme is pretty important. You can kind of see in this package here, we have, or hopefully you can see it. I don't really think I can zoom in on this window. You have color, shape, theme, and types. Another common one that you'll see when developing kind of compose at an enterprise level is the dimensions of things. And to give you kind of a specific example, at Peloton, Peloton's Android repo is responsible for not only the phone's digital Android app, which you can download, it's also the entire tablet on the Peloton device. It's also a different application entirely that it runs on a separate piece of hardware. So multiple devices, multiple kind of environments are being set up. You're going to want different dimensions to sort of support that. A button that someone presses on their Pixel, you want to use the same button class and the same theme. And you can kind of tell your theme from a high level, hey, you need to make this button a lot bigger. I'm doing this on, a 40-inch tablet versus, I want this on an iPhone here. Dimensions can kind of help you do that. If you work with a design system and say standard sizes of things can kind of propagate across, different devices, you can say, hey, I want this to be 5 units long. That's going to work on both a smaller device like this and a larger device like a Peloton tablet. Now, shapes is also a pretty interesting one here. The rounded corner shapes kind of just have their sizes. You're going to get these for free as well if you want to change the shape of something based off the composition. Really what the theme is responsible for is giving kind of a global context on these sorts of pieces here. You don't have to call colors directly as I did down below. You really just can call background on it. And in the case of colors, let's say a big system configuration change you're going to want to handle is dark mode. If your app doesn't have dark mode, it's something that a lot of people prefer. I know personally, I like looking at dark mode. I'm clearly using the Darkula theme on Android Studio here. Being able to sort of set up your theme means that this is going to respond to configuration changes, specifically around background. I believe if I go in here in the emulator settings and actually switch on dark theme, supported apps will switch to that. Very cool. Changes pretty much everything. Let's go ahead and open up my app here. You can see that right away the background changes without having any code changes here. That's really one of the most crucial examples of using a theme is with colors. Additionally, you have typography. This is really just a way to kind of define a style that goes throughout your entire project. Now, I've kind of heard modifiers, which you guys learned about last class, be compared to CSS and style sheets. You want to think about this as sort of like a theme that goes on top of those style sheets here. So defining all of your text to be reused across all of your views is something that you would want to put from within the theme here. There is a very good example of this on Jet Survey, so I might try to do that. I'm a little concerned it's going to crash because it wasn't playing super nice beforehand. But let's kind of like take a look at what a theme looks like kind of in practice in this survey example here. In this case, we are still doing a little bit of indexing, so I'm not going to get my sweet syntax highlighting, but you can kind of see right away with this theme. Go ahead and move to the project view. This is sort of what's being used in all the color constants. So you have this file, which kind of declares globally your internal values. You would never want to refer to one of these themes kind of in line within your code. You always kind of want to do it through the theme value so that on a configuration change, your app will automatically respond to that. You can see here, we have our two kind of color schemes, the light mode and dark mode. And then this is kind of what calls all of those individual constants that we declared from within this class here. We also have our typography. Once again, you kind of declare a font family that everything works off of, and your display size will automatically kind of be supported based off of things like text changing. Using this SP already kind of does that automatically, but this is to kind of make sure that if you want large font, it's going to scale properly across all of them. So if you have large font as a header, medium font as a subheader, and small font as kind of a detail text size, someone goes through and raises the text size for everything, it's going to kind of change every view from within that and actually propagate through. I believe that is everything for theme. An important thing is that if you do create a theme and you have your preview here, it is important to include that theme from within the preview. I can actually go ahead and show you kind of an example of that with just the split design here. You can see we got a little build error. You might need to run that. It's looking for a color. I'm just going to go ahead and push that here. The whole file needs to be properly syntaxed in the case of theming. So we have our default compose application theme here. You can see the typography is a material typography. We're using kind of the default font family. Let's try out what a cursive one looks like to sort of go back and see that from within our view. It says this is up to date, but if we build and refresh, we have our cute little hello Android there in cursive now. Let's see what this looks like if you remove the theme context and then rerun it. You can kind of see it goes back to this very basic text style here, and it's no longer sort of respecting our theme that we've declared here. So very important that you keep your preview on the actual theming if you want to see how it would look in an actual compiled device. It switches right away with auto update. Auto update works like 50% of the time, by the way. So if it's ever giving you kind of issues, you can mess around with the settings a little bit on the actual split window here. I believe there's some settings on this side as well. I don't know why they have the design window. I think this made sense for XML, but you really can't do anything in Compose. But yeah, you can see that wrapping the theme is important for any subview, and it's going to hold any view outside of that as well. So really, all you need to do is worry about your theme on the topmost level of your Compose screen here. In the case of this, we have our navigation, our nav host here with welcome routes. On the highest level of the entire app, the theme is even put before the navigation host. If you've worked with fragment navigation controllers, this is really like basically having an application XML file and then activities within it. This is really your highest level theming, and you don't ever need to repeat it anywhere throughout the app, except for in the previews, which is kind of where you can see it being reused in the Jet Survey project. Within here, you don't need to worry about that because on the higher level within the actual code base, it's already declared. All right. I didn't record what time we've started, but I think we can try to go over lazy lists. Yeah, cool. All right. So we have our lovely view and compose application. The cursive looked nice for an example, but I definitely do not want that because it is a little hard to look at. Let's kind of take an example of a lazy list and kind of show you how it differs from just using a column. We have our event handling example here. Let's go ahead and make a new composable. Actually, we can just reuse this greeting one, get rid of that, and go ahead and make this so that instead of having name, you have names, which will be a list of strings. All right. So, you could do this in a column, right? Add the column scope, names dot for each. And then we have maybe our text function with the name kind of being your most basic example here. If we display greeting as a preview, we have to give it a list of names here. We're just going to do this all inline. I go through and give ourselves some names to work with here. Cool. So you can see all that kind of gets added nice and cleanly on the front piece here. Any sort of name that you add is going to be done as well. This works fine because obviously, what is this? 7 names or something? 6 names. That's a pretty small number. It doesn't really matter if we build the whole screen at once. That's going to be fine to compile. Now, if list of kind of becomes, 100 more items or maybe 1,000 more items, Compose is going to try to draw this entire list and render it all with these 1,000 items, basically until it can fill the screen size. And even actually off of the screen, the compiler is going to be trying to handle that. You use a recycler view to kind of avoid that. And in a similar way, you use a lazy list to kind of avoid that. So column's great, but let's try putting a lazy column in. Now, this is kind of important. What you do with the content here is give it actually your composable. So we can just do brackets here and omit that named function. We want to get rid of names.forEach. And now we're kind of, as you can see, we're using this lazy list scope. Remember when we were having a button, we had row scope. Now with a lazy column, we have lazy list scope. What the API for this looks like, and I actually think they do kind of follow that a little bit on here. Or I might be mistaken. Do you know if they do the lazy list in their layout here? Okay. Yeah. I mean, it probably would have been more confusing anyways. I could probably just explain it here. Anyways, basically what you want to do is anytime you want to declare an item, you use this item bracket here. It knows that you have a, something that you want to put within this list here. So we can go ahead and add the item on this level. Say text becomes, actually, the way you really want to do this is names.forEach item and then text with it. It might yell at me for having that here. You can see our preview works again. Let's actually go ahead and do a little bit of computation here. I think we can do an inline list and actually create something. I believe with that you have to do, here we go. Let's go to 200. For each, actually map, and then we'll do it.toString. What this is saying is that I want a list inclusive from 1 to 200, and I'm just going to print out every single number of that. You can see this list is massive. I mean, it's already going to scroll throughout this piece here. Within our items, we have in the greeting class here, I really need to move those composables around. All we're doing is printing it out. That's fine. This is kind of the basic way of doing that is with this item within the for each. If you really want to get fancy with it, and it's probably the preferred way of doing it, if you know you're going to have a large list, is you can use this items API. In this case, we give it the list of names, and now we know it's looking for an int. Oh, the count. There we go. Names.size. And then we can see our item content is actually what's going to render it. This is where we declare what the view looks like within this piece here. We're going to go ahead and make a text field using it. And you can actually see that we have both the scope of the column itself as well as the value from the list of items, it right here. So we can just go ahead and do that. It's a number, so we'll go ahead and do a toString. My preview is going to render on the right here, and we can see that all of our values are showing up. We'll make this a little bit prettier and add some horizontal alignment. Very cool. our text value is showing up here. This is great, and we have a bunch of items. You know, it looks fine on this here. We can go ahead and call greeting with the names. I'm going to go ahead and copy my nice little algorithm here to just spin up an example. But you know what? Let's give it something a little bit trickier to work with. How about 20,000 names? Let's see how our code works with that. All right, and you can see I can't scroll. It's a very important detail that you need to actually add a scroll state to these pieces here. User scroll enabled, I don't believe has an initial value. I mean, probably does. Okay, so it is enabled. We kind of just have to pass it the actual scroll state and behavior here. So we can do that with remember scroll state. We have to give it an orientation as well. It would be nice to go vertically, but it's not really what we're or horizontally, but it's not really what we're interested in here. Okay, and now you can see I can scroll through my 200 or so values with ease on this level. Okay. So what's interesting is that they actually are centered. It's really just that this text bubble here is going to fill the size of the parent kind of in a composable method. So if we actually kind of draw this out a little bit more, text equals that, give it a size parameter. Once again, that has to be a modifier dot size, or I think we could just do wrap content width. This should make each of the texts only as large as the value itself, although it looks like it did not. Modifier dot size. Go ahead and give it 30 dp. Okay, so it worked on the vertical level here, but it didn't on the level before it. That's okay. We can just look at the piece before. I also probably want to get rid of that. This surface is filling the max size here. Our lazy column is also going to be filling the max width as well. So we can go ahead and add, we have our scrollable state here. Give it a modifier dot width and make it 40 dp. And we're still not vertically centered. All right. Under the width here. Potentially it has something to do with the parent view. A good way to kind of debug these sorts of things is by adding a background to them. So we can kind of see what size this is by adding sort of a background to it. Let's go ahead and add our on background, I suppose, and just sort of check what our lazy columns width is. Okay, so you can see right here, 40 dp is not very large for this to be. Our items are also not aligned here. The reason why I think is because the actual text box has a different alignment. Alignment can be very tricky. So you're probably going to be able to see it's centered within this here.
If you want to make the modifier be fill max width.
Yeah, so you definitely could do that on this level here. Yeah. That was just to kind of illustrate like the piece of it there. So there you go. Our text is only a certain size here. You probably don't need to add that, but sometimes it's the text alignment in itself that can mess around with it. Is there any other questions? Or cool. All right. So let's get a little fancier with it. These are fine, but what if you actually kind of want to communicate a state to this lazy column and kind of go a little bit deeper in that aspect of it? So let's go ahead and say we have this list of names here, and we want to color something based off of an onClick. So let's make another remember statement. We'll call it red index. I remember an eager compiler. Mutable state of 0. Now we're going to change something within here. Color equals if red index. You see we have access to the index of the value with this sort of int value here. We have our it. So if red index equals it, color dot else and these colors you would probably want to use material theme to respect, kind of as we were talking about before, but just kind of for example's sake, we'll go through here. We're not actually changing everything about it, but you can see our 0 is playing nice above. We have that right there. I think potentially, it's because yeah, it's not going up to 2000. Maybe there's a limit there, but let's actually kind of add an onClick to this text to make it so that we can choose which one is red and then change the index of it. That can be done with a modifier. So we'll do modifier.clickable. And we'll go ahead and change the var. Sometimes like compose can act strange with this sort of like tertiary level of indexing I found in terms of like tabs, but we'll go ahead and change red index here to whichever one gets clicked. We are using a lot of its here, and sometimes compose gets mad at that. They kind of want you to, use an explicit lambda, as they'll call it. So just to make it a little bit more readable, you can refactor that to be current number. So red index becomes whatever the current number is, and that's going to trigger a recomposition on these values here. So let's rerun that and see if that works. Starting off with our initial. There we go. You kind of see how state is communicated back to this remember at the top. And then within our actual value here, we can kind of go down. A classic recycler view bug is that it will not remember the index when you scroll down from it. So you'll set something in like index 2, you'll scroll down 10 pages and it will reconfigure that as index 2 and it will perform an operation. With this items in lazy column API, that doesn't happen. We can scroll all the way back to the top and you can see lucky 16 is checked just the same as it was. Similarly, if you kind of select something down, go back to the top, that same error doesn't happen. They seem to have fixed that under the hood. Again, really only something if you've worked in like a social application where there's like likes or something associated with that. But your remember is going to keep that context throughout the scrollable state here. So important kind of takeaways for lazy column. Doesn't have to be a lazy column. You can use a lazy row as well, obviously. Lazy grid is something that works too. Maybe you have a Photos app or something where you're kind of displaying things in a basic kind of a grid level. The important thing is that any single time you want to use the items API, where you're kind of generating these values in a smart manner, you do need to use a lazy column. And anytime you're displaying something that's coming from a backend, or maybe you're not sure how many values are going to be in the list, it's definitely recommended that you do that through the lazy column value here. There's some really good documentation on this sort of thing on kind of the compose actual docs. And once again, I can answer any sort of questions about that. I think I can do just one more tiny thing and then probably wrap up. Cool. Yeah, so I did promise to talk a little bit about animations, and I did kind of just have an idea for one. So this is going to be a really basic example of how we can actually grow a composable in an animated fashion with a composable called animate content size. Cool. So I did kind of mention this before, but just briefly, I want to show off this diagram. Really, like there's nothing like I know I've talked this up, but there's nothing like this in XML. And animations are notoriously heinous to have to work with. But you can kind of see here that it pretty much tells you which library you have to use for anything. And this flowchart, I mean, it feels kind of dumb, but it really does work in terms of answering your questions on things. So, let's say you have a content change here. You want to animate appearances, animated visibility kind of provides a nice fade there. Let's say, it's not appearance, disappearance, it's content size. This is what we're going to be using here. You have animate content size. This is nice because it's just a modifier. So, literally at the most basic level, animate content size is just like an additional dot function that you add on. So let's go back to our example here and go ahead and modify greeting a little bit so that we have a on click here. Cool. So really what we're going to want to do is not give ourselves this many items. Maybe let's start with a mutable variable on this level. Mutable state of, mutable list of, gotta give it some value here. Let's go ahead and do string. Cool. So names, which was a list of ints, is going to be now list here. We have our second argument of greetings, which we can do by declaring on click here. It's general practice to keep a lambda argument if you're going to do it with compose as the last one, so that you can actually make it a little bit more readable, and then just toss the lambda here, and it will implicitly know that this is you making the on click right there. So anytime you click, we're going to add something to list here. So list dot add a new name. We're just going to have a bunch of cigars on this one. So cool. We got our list. We have our on click set here. We're not actually doing anything with it though. Our scrollable state is here, and that's fine and dandy. Let's go ahead and add a button on top of that, which we'll call our on click. Press for more cigar. Beautiful. Sometimes you can forget that you do need to wrap things with text. You're not doing that. It only happens within the context of a composable. Anything that happens within the list scope has to have that item around it, which is why it's going to yell at us. But cool. We have our values here with the red index. I'm just going to make the background a different color here. Again, I'm really not sure which these colors are. I'm hoping secondary isn't purple. I guess we're just going to have to find out. Material theme, I believe secondary is purple. Regardless, it's going to start off as a pretty small list and then kind of grow as we add this button. But the most important thing is that, we have our modifiers here, fill max width, scrollable, background. But what we really want to do is this animate content size. And that's literally all you need to add an animation to this here. Now, of course, there are more finite specs you can do with them. Like if you want to look at the finite animation spec, maybe you want to change things. A finished listener is helpful if you have some sort of operation going off of the size. But in this case, we really just want to see it flow a little bit smoother. So let's go ahead and type that in and see how it runs. And a nice compilation error. Very, very nice. Get rid of that. Okay. We don't see anything. Nice. Well, our list does start off empty. which is kind of important because lazy column might not like that we don't have any items in the column. I'm going to go ahead and just, for the sake of this animate demo, not make it a lazy column, and then just do names dot for each. Cool. So yeah, kind of removing a lot of the kind of infinite drawable aspect that we had with that recycler view library here, and I'm going to get rid of our nice color logic that we had. But you can see that names is going to be growing from the mutable state. Okay, still cannot see it. Let's see. Surface filling max size. Oh, you know, it might be that the background secondary color is just white. We're going to make this look real nice. All right, so we're actually not drawing the column at all here. Are we aligned? Center horizontally. Animate content size. Sometimes if you aren't getting views to work well, it's important to mess around with the modifier order. One of the hardest things to kind of wrap your head around is that modifiers do matter in terms of the order that you put them. So if you put scrollable potentially in the wrong spot, it might not actually, you know, fill your view here. I'm realizing also that I probably want to fill the max size of the whole screen, because I bet I had no height. Still not seeing anything on here. This is in the column scope. All right. I wonder if it's with the content size animation. Nope. Okay. So then we know something is wrong with here. I'll go ahead and give this some values that we're actually working with here. Yeah. Oh my gosh. Okay. This is what was happening. The app wasn't running. It was the preview that was running on a device. So I'm glad that, you know, it wasn't something within the code here, but this is important. When you click on this, you're actually just running the preview, which is why previously it only went up to 200. I was running the preview as if it was kind of a standalone application. Now I have a standalone application, which is what I was modifying, but it wasn't the preview here. So there's two ways you can kind of view previews. There's this kind of side-by-side split aspect here. And then there is the actual like running it on a device, which you can do with this button here. Pay attention to this top value because you might end up embarrassing yourself adding names to things. Okay, it looks like our text isn't wide enough. I'll go ahead and make it just a little bit bigger. You can see this is filling the max size. We don't really want it to do that. Let's have it. Graph our actual content size. Cool. All right. Now something is happening with this aspect. We don't necessarily need it to be scrollable. Let's try to attach. Again, let's see how sometimes the order of the composables functions makes sense. Yeah, so before you actually add your background size, you can see that this gets changed here. I want to go ahead and keep that at the bottom as it was. And let's animate content size. All right, list is getting fed into this. It doesn't think that we're adding anything to list. Some classic print line debugging. No one grows out of this one here. Looks like all those errors are finally coming back at us. Okay, so it is adding the name. It's just not changing the composable here. It's not actually recomposing it. I'm at a little bit of a loss for why it's not doing that. Potentially something to do with this value here. We could just put the list of names kind of as an internal value here instead of our on click here. Kind of make our local names. I remember mutable state of names. And then every time we want to use that, we'll do local names. We'll switch our on click to be local names dot okay. Mutability is very important in this. All right, let's see if switching the context of this locally is going to reconfigure this column here. All right, and once again, we are not adding that to this list. Do you guys see anything wrong with this cigar potentially? Oh, like attach the debugger to it? Yeah, I wonder if I can also print line the list of names. See if it actually is adding it. Additionally, I can do a
list stable, maybe it's an immutable list.
Well, we are using local names here, which I think we do have.
Compose can be very finicky, but stable data not. So maybe because this is a list, the equals is not enough.
That's
you know what I mean? So
yeah.
The list itself is the same list, just has more items. Maybe immutable list, so it changes the list underneath itself. I'm just spitballing it.
Yeah.
I know that the immutability stable is very important because the equals or the equality might not be.
So we are adding them
so
here.
Composer, yeah, nothing changed.
Yeah.
So it's the modifier which you are using for column, which is allowing, which is preventing it to expand.
Right. I wonder if wrapping the content size of it actually will change anything. Yeah, I wonder. Because now it's not even redrawing that. Well, folks, I do apologize on this one. I'm seemingly missing something here. But I think, basically the animate content size is something that, when something gets added here, you could pretty much add it to any sort of item here. It doesn't actually have to be a running project. So potentially we could add it here as well. It's really simple to use it just anytime you think there's going to be a state change that feeds into an object. The animate content size is really just going to, have kind of an in-between animation on the size of it itself. So I apologize I wasn't able to get that example working. I'm sure if you tinkered at it a little bit, you can, and maybe I can toss some example code in after or figure out what was going on there. But yeah, I think that about wraps up. I know we're a little bit over on time, like an hour and a half right now, I believe. But let me go ahead and stop sharing my screen. Very nice. Yeah. Can you nest lazy rows within lazy columns? The answer is yes. Generally, I would say that might be an intensive process, just like thinking about it logistically. I mean, you're going to have a lot of things kind of growing at once. And anytime you want to like change, let's say, you have a list of items that you sort of scroll in within them. You're going to have to be computing anything that you scroll horizontally just as much as you're also recalculating the parent list. So you're getting into a little bit of kind of like an n squared optimization thing there. I would suggest avoiding it if you can. It's generally also a little bit easier to work with too. The sizing is going to be a lot trickier if you have a kind of a lazy row within a lazy column too, and in working around that, it's kind of just better to keep your degrees of freedom to 1 in terms of, and unexpected inputs. And yeah, I think if there's no other questions, that about wraps it up. Thank you guys for, struggling with me for a little bit at the end there. I hope you did learn something though, to kind of just go over everything we went through. Event handling is really how you send triggers from your composables to the parent view and kind of have some logic go based off of that. Your remember statement is what kind of holds state internally and allows you to recompose things on the local composable level. You use themes to kind of support multiple devices, dark modes, and be able to kind of do things throughout columns. And finally, the lazy list is really what you want to use if there's ever going to be an unexpected amount of items that you want to be computed and maybe not to be all compiled at once. Well, I hope you guys enjoyed. I think next Wednesday we have lesson 3 of Compose Camp. Cigar, maybe you want to share a little bit about what we're learning there? We're going to talk about it in the channel a little bit. I think there is one other question. Are the camps being recorded? Cool. We are recording them. So you can come back anytime and watch me compile the preview instead of the app or make a fool of myself. But yeah, have a great Wednesday, guys. I hope you all enjoyed. And thanks for having me. Thank you.
Thank you.